All right, let's talk about something that's absolutely fundamental to making AI systems work, but it almost never gets the spotlight. We're diving deep into document chunking. It might sound technical, but trust me, it's the unsung hero that decides if your AI is brilliant or just, well, broken. So yeah, let's get into it.
So what's the big problem we're even trying to solve here? Well, it all starts with a core weakness in large language models. You see, LLMs are trained on just a mind-boggling amount of text from the internet, and sometimes that text disagrees with itself. This can cause the model to hold two completely opposite ideas at the same time. And in fields like medicine, that's not just a little mistake, that's genuinely dangerous.
And you know, these problems actually have names. The first is concept drift. That's just a fancy way of saying the world changes and the AI's old training data becomes stale. Think of old medical advice. The other one is internal inconsistencies, which is when the model learns conflicting facts from different places. Put them together, and you've got a recipe for an AI you just can't trust. So, what do we do about it?
Well, this is where our hero enters the scene, RAG. It stands for Retrieval-Augmented Generation, and it's a super powerful technique designed to chain these powerful AI brains to a source of truth that we control and trust. At its heart, RAG is a pretty simple but totally brilliant idea. Instead of just letting the LLM answer from its vast, messy memory, we first go and retrieve the most relevant, up-to-date facts from our own private library of data. Then, we hand those facts to the LLM and say, okay, now answer the question, but only using this information. It grounds the model in reality.
Okay, so let's walk through how this actually works. It all starts with your raw data, your documents. First, you break them up into smaller pieces, or chunks. Then, you convert those chunks into a special numerical format called an embedding and store them. When you ask a question, your question also gets turned into an embedding. The system then plays a game of matchmaker, finding the data chunks that are the closest match to your question. Finally, it bundles up your question and those perfect little chunks of info and hands them over to the LLM for a smart, grounded answer.
But, and this is a huge but, just setting up a RAG pipeline isn't a magic bullet. The real secret sauce, the part where projects either succeed or fail, is in that very first step, how you prepare your data, how you actually break those documents into chunks.
And I really want you to let that sink in for a second. Chunking is, and I'm not exaggerating, the most important piece of the puzzle. You could have the world's best AI model and the fastest database, but if your chunks are bad, the whole system just falls apart. Garbage in, garbage out, right?
This is the big challenge. It's a real Goldilocks problem. If your chunks are too small, like a single sentence ripped from a paragraph, they lose all their context. It's like asking a researcher a question but only giving them one random sentence from a book. Useless, right? But if your chunks are too big, you get two other problems. First, the most important detail might get buried in the middle, and AIs have this weird habit of ignoring stuff in the middle of long texts. Second, the chunk contains so many different ideas that its embedding becomes noisy and generic, making it really hard for the system to find it when it's needed.
So another big decision you got to make is when to do all this splitting. The normal way is pre-chunking. You chop everything up front before anyone asks a single question. It's fast because all the heavy lifting is done. The more advanced way is post-chunking, where you actually find the most relevant whole documents first, and then you chunk them up on the fly. It's way more flexible, but as you can imagine, a little bit slower.
All right, now that we've got the why and the when down, let's get into the really fun stuff, the what. We're going to take a tour of the most common and powerful chunking strategies out there right now.
And we're going to start with the basics. Think of these as the bread and butter, the foundational building blocks that you're going to see in almost every RAG system you come across.
First up is fixed size chunking. It's the simplest tool in the toolbox. You basically just take a giant pair of scissors and cut your text every, say, 500 characters. It's crude, it's fast, but it often cuts sentences right in half. To get around that, we usually add a little overlap, so the end of one chunk is also the beginning of the next, just to give the AI some context.
A step up from that is recursive chunking. This one's a little smarter because it tries to respect the structure of the document. It has a list of priorities. It'll try to split by paragraphs first. If a paragraph is still too big, then it'll try to split that paragraph by sentences. It keeps going down the list until the chunks are the right size. It's much better at keeping related ideas together.
And building on that is document-based chunking, which is exactly what it sounds like, and it's super logical. If your file is already well structured, like a markdown document with headers and subheaders, or a piece of code with functions, you just use that existing structure as your guide. Each heading or each function can become its own chunk, simple and effective.
Okay, so we've seen the basics. Now, let's level up and look at the really advanced stuff, the techniques that try to understand the meaning of the text to make truly intelligent cuts.
This is where things get really cool. Semantic chunking doesn't care about paragraphs or sentence breaks. Instead, it analyzes the meaning of the words and makes a cut at the precise moment the topic changes. It finds the natural thematic breaks in the writing. This is amazing for creating chunks that contain one single, complete idea, which is perfect for really dense legal or scientific papers.
Now, what if you're not sure which strategy to use? Well, you could use agentic chunking. Think of this as hiring a little AI expert to do the chunking for you. You give it a document, and it analyzes it and decides the best way to break it apart. It might use one strategy for the introduction and a totally different one for the conclusion. It's incredibly powerful, but as you can guess, it's also pretty slow and expensive.
And finally, we have late chunking. This is a really clever way to solve that out-of-context problem we talked about earlier. Instead of chopping a document into isolated pieces, it first creates an embedding for the entire document. Then it creates smaller chunks that still have an awareness of their place in the big picture. It's ideal for documents with tons of cross-references, making sure every little piece knows what the whole thing is about.
Okay, wow, that was a lot of different strategies, right? So the big question is, how on earth do you choose which one is right for your project? Let's break that down.
Let's put this all together in a nice little cheat sheet. As you can see, there's no single best method. It all depends. If you're just building a quick prototype, fixed size is totally fine. Got a bunch of blog articles? Recursive is probably your best bet. If you're working with something highly structured like code, then document-based is a no-brainer. But if you're dealing with really dense, complex documents where every nuance matters, you're going to want to look at the big guns: semantic, agentic, or layered chunking. The key thing to remember is this: let your data guide your decision.
And that really brings us to a fascinating paradox, doesn't it? To help an AI understand the whole picture, to make knowledge complete and useful for it, our first job is to master the art of breaking that knowledge into the perfect tiny pieces. It's this careful act of taking things apart that, in the end, allows the AI to put them back together in a way that truly makes sense.